All right, so our goal today is to write and interpret direct variation equations. So, direct variation. This is actually just a continuation of what we were doing in 2.2. 2.2, we were talking about linear equations. This is a type of a linear equation. So what did it look like when we graphed a linear equation? What did it look like on a graph? What did all of our graphs have on them? Bunch of points. Then when you connect them, what's it make? A line. Yeah, a line. They were all a straight line, right? So this is just another version of that. It's also a straight line if we were to graph it. But the important thing about a direct variation is the y-intercept, okay, goes through the point 0, 0. So it has to go through the origin. So this is a linear function, a direct variation. With the y-intercept at 0, 0. So what it's going to look like, if we wrote it in like y equals mx plus b form, instead of having y equals mx plus b, we're going to write the slope as k, y equals kx. I'm not going to write plus b because what's the b value? 0. If it has to go through the point 0, 0, that b value would be 0 because b is your y-intercept. So this is what the equation looks like, y equals kx. Okay. The big part about it, it goes through, it's just a straight line that goes through the origin. The origin is that point 0, 0. So, some examples would be like, it's going to be in this format, and the k value is just a number. It could be any number. So it could be y equals 7x. Could be y equals 2/3 x. Could be y equals negative 5/4 x. Okay, that's just a number times x. Okay, that number is our slope. So it looks just like y equals mx plus b, but we don't have to worry about the plus b anymore because it's always going to be 0. And it's not necessary to write plus 0. The constant of variation, this is the k value. Okay? It is the ratio of y to x. This would also be considered, if you're looking at where k is, that's the slope of a direct variation graph. Okay, it's going to be the slope on the graph. In order for a function to be a direct variation, the ratio y to x must be constant for all of its ordered pairs. Okay? The ratio y to x, well, we said that was your k value. And if your slope is y equals kx, that means your slope always has to be the same. It doesn't matter which 2 points you choose, your slope's always the same when you have a straight line. That's what we've been talking about with linear equations. This is the same idea. That ratio, which comes out to be your slope, has to remain the same all the time. Okay? The function must go through the origin. So if you were to graph this, it has to go through the point 0, 0. Both of those things have to be true in order for it to be a direct variation. Okay, if I were to plot these, I have to be able to take a straight edge, connect all the points. If they connect with a straight line, that means it has a constant slope. And if it's going through the origin, it's direct variation. Those are the two big ideas. So, we can find our k value. The ratio is just a fraction. Here is how you come up with the k value, though. Y equals kx. How do you get k by itself? What's happening right now between k and x?
Divide by x.
We're going to have to divide both sides by x. It's multiplication that's happening, so to undo it, you're going to have to divide both sides by x. Your x's will go away on the right, and you have that your k value is equal to y over x. And your k value always has to remain the same. Okay? What it's really doing here is if you took the point 0, 0, and did your slope equation, the y2 minus y1, we're taking y, but we'd subtract 0 from it. You'd take your x, you'd subtract 0 from it. So really, if you just do the y over x, you'll find your slope. Now, this only works with direct variation, though, not all linear equations, because they don't all go through the origin. Okay. So to identify if this table is a direct variation, we have to find the slope between 0, 0 and this coordinate point for all of them. And in order to do that, we're just doing y over x. So here, y over x is 21 over 3. But reduce it. What do we get? 7. Here, y over x is 35 over 5. Now reduce it. 7. Take the bottom one. Y over x is 63 over 9. Reduce it. 7. So is this a direct variation? Is your k always the same? And if it is, you can answer yes. What's your k value? What did we find your k value to be? If I had to write an equation, how would I write the equation? Y equals what? 7x. Y equals 7x. Y equals kx. You're just going to fill in that k value as 7. Give me a 1 through 5. I'm with you, Mrs. Fox. Down to a 1. I lost Mrs. Fox. All right, cool. Let's try the next one. We're going to find our k value the same way. K is equal to y over x. K is always equal to y over x. You can always find k value that way. Okay, so go ahead right now and find the k value for those three. All right, what did you guys get for the k value for the 0.28? K is 4? Raise your hand if you got k is 4. Okay, cool. What k value did you get for the 0.416? 4. Okay, cool. I heard quite a few of them. How about for the k value for the 0.632? 16 over 3. Okay, yes, if you found 5.333, that's fine for your work. But if that was a constant k value, we would not be allowed to write 5.33 for your k value. You'd have to write it as a fraction. So you'd have to go back up here and say 32 over 6, reduce it, divide both the top and bottom by 2, and you'd have 16/3. So is this a direct variation? Was your k value the same the entire time? No. So we answer no. We do not have to move on. You can write NA for not available or put a giant X through it. You do not have to find the k value because there's not a k value unless it is a direct variation. Are we good with that? All right, so the next one says determine whether y varies directly with x. So we have to look at the equation and see if we can manipulate the equation so it looks like y equals a number x. Y is not alone in this first one. What do we have to do to get y by itself? Divide by 3. I get y equals 2/3 x. Is this a direct variation equation? Yes, it's in the form of y equals kx, y equals a number x. So I'd answer yes. And then it says, if so, find the constant of variation. That's your k value. The constant of variation, every time you see that, think about k. It's looking for the k value. And when it says y varies directly with x, this says y equals kx. Is that what it looks like? So get in the habit of writing that right in the directions. Does it look like this? Find the constant of variation. That's k. So what's your k value for part A? 2 over 3. So those are your two big parts to your answer. For part B, y equals negative 2x plus 3. Does this look like y equals kx? No, why not? It has a b value, and that b value is supposed to be 0. So because of that, it doesn't work. You put no. You don't even have to worry about that k value. Your answer is just no. All good? All right, let's look at the last one. Is y by itself? Not yet. Minus 7 is also on that side, so we have to get rid of it. What are we going to do to get y alone? Add 7 to both sides. Is 9x and 7, are those like terms? Are 9x and 7 like terms? No, so we can't combine them. So it becomes y equals 9x plus 7. We have to leave them separate because they weren't like terms. Y equals 9x plus 7, is that a direct variation equation? Does that look like y equals kx? Nope, so we answer no. And we don't have to move on to find the k value because it's not a direct variation. So this says, for each direct variation, find the constant of variation. So we're going to, again, the constant of variation, that's your k value. So we're going to have to find k for each of these. Oh, you guys can't even see what I'm writing. You guys got to warn me about that. All right, for each direct variation, find the constant of variation. So that's the k value. Okay, then it asks me to find something else. We'll worry about that in a minute. All right, well, I have a point right here. This is a point, 2, 6. Okay, I can do this two different ways. I know that my equation has to look like this, y equals kx, right? I know that's what my equation has to look like. So I can plug in y is 6 equals k, x is 2, because that's what the point is. And I can solve for k. How do I get k alone? Divide both sides by 2. What's your k value? 3. So there we go. K is 3. I just rewrite it because I like k on the left. All right, so k is 3. That's my constant of variation. That allows you to write your equation. That means my equation is y equals 3x. Okay, then it says, then find the value of y when x is negative 2. So wait a minute. It tells you x is negative 2. It wants you to find y. So I have this point, negative 2, I don't know what the y value is. But now that I have the equation, what I can do is I can plug in negative 2 for x. And I can solve for y. Y has to be what? What's 3 times negative 2? So I found the y value also. Are we okay with that? Give me a 1 through 5, I'm with you. I don't know where you went. All right, the next equation, I'm going to show you the other way that you could find how to write this equation. On the front side, how were we finding k before? What were we doing to find k when we were doing this table? We put y over x. K is always y over x. So you could figure it out by saying, okay, here's a point. I know that k is y over x. So k has to be y is 15, x is negative 8. There's your k value. From there, you can write your equation. Y equals 15 over negative 8, because that doesn't reduce at all, x. Oh wait, that was part of our answer, right? We had to find k. So we actually found k in like one step versus here it took us a couple steps. Do you see the difference? That's the only thing that's different in how I'm going to solve A and B. So you can find K by plugging it into your equation, or you can use your equation for K. It doesn't matter which one you use. As long as you can find K, I'll be happy. Okie doke. What's our next step though? Because we still have to find the value of y when x is -2. So what am I going to do now that I have this equation? Well, I have -2. I'm looking for the y value. No, because it's 15 when x was -8. So it's not going to be 15 because it's 15 when x is -8. X is now -2. We have to find the y value that goes with that point. So I'm going to have to use my equation. What do I do? Plug in -2 for x. So y equals, again, it doesn't matter where that negative sign goes as long as you have 15/8 and one negative sign. The x value is -2. And now we can simplify it. Well, a negative times a negative is going to be a positive. So 15 times 2 is 30/8. And then what number goes into 30 and into 8? 2. So divide both by 2. We get 15/4. Is there any number that goes into 15 and into 4? Then that looks like that's your final answer there. Y is 15/4. Are we okay so far? So that we did the exact same way as we did the second one. We had our equation. We plugged in the x that we knew to find our y value. So the second part we did the exact same way. The only part different was you could either plug it into your original equation and solve for k, or if you know k is y/x, you can do it that route too. And you get to choose. All right, story problems. Every time we see a direct variation story problem, it says varies directly with, right in it. And usually it says y varies directly with x. And if it says that, we know that y comes first, then it goes equals k, and then comes your x. So y varies directly with x says y equals kx. Are you with me? So here, this says y varies directly with x. It is actually already telling you that your water wasted has to be y, because that comes first. Varies directly with says equals k, and then it tells you time must be x because that's what comes next. Are you with me? So what this says is y is equal to the amount of water that is wasted. And your x has to be the time. Now it tells you 1 cup of water is wasted after 3 minutes. That is giving you 1 point. Okay? I can see that the amount of water that's wasted is measured in cups. So I'm going to write that right here. And the time is measured how? In what unit? What's time measured in? Minutes. So I'm going to write that down too. The information that's given tells you a point. What is the x value or the time in that sentence? 3. What is the y value or the water wasted in that sentence? What is it? 1. It says 1 cup of water is wasted after 3 minutes. So that gives us a point. Okay, let's read the next sentence. It says, write an equation to calculate how much water is wasted each minute. So all we're going to do is we have this point. We know it's direct variation, so we have to write the equation in the form of y equals kx. Well, we have to find our k value. Now, I've shown you 2 ways to find the k value. And you can choose at this point which way you want to use. So we can either fill it in your equation and solve for k and rewrite it, or you can use the k formula I told you. What is the k formula? K equals what? What's the k formula? Y over x. So k has to be, what was the y value in our green point right here? Y is 1 over, what's the x value? 3. So k is 1/3. We go and write our equation, y equals 1/3 x. That is your equation. So we're doing this the exact same way we did for example 3. Okay, then it says, that's writing an equation to calculate how much water is wasted after each minute. Sure, we did that. How much water is wasted after 9 minutes? Okay, let me find a different color here. Here's orange. How much water is wasted after 9 minutes? So what do I have? Do I have x or do I have y with that point? If I have 9 minutes, is that x or is it y? It's x. X is time. So I know I have x there. That means I don't know what y is because it says how much water is wasted. The water wasted is y, so that's what I'm looking for. Well, I have my equation now. So I have y is what? I don't know. 1/3. What's your x? 9. Because that's what was in that point. I'm trying to find the y for that point. Okay, so y equals 1/3 of 9, or 9 times 1 is 9, divided by 3 is 3. So I'm going to have, after 9 minutes, how much water is wasted? 3 cups. So I had my equation, and I found how much water was wasted after 9 minutes. Okay. You do have one story problem. If you do it just like what we did this one, first figure out what's x and what's y, just like we did in this sentence right here. Y comes first, water wasted is your y, varies directly with x comes next, so time has to be x. And then read the sentence, it'll give you a point. So write down the point. Figure out your equation based on that point that was given. Once you have the equation, it'll give you another piece of information and you have to find the other part to that new point. Okay. All right, so our last example here says y varies directly with x, meaning that y equals kx. If y is 10 when x is 3, find x when y is 6. Okay. We can do the exact same thing that we've been doing. We have 1 point, and we have an x that's unknown, and a y that is known, so we have a second point. We can use the first point to write the k value, write the equation, plug in the y of the second point to find the x of that second point. We can do that all in the same way that we did before. But since this does not tell you to find k and to write the equation, there is a shortcut method you can use, and I'm going to show you how we can do this. Okay? Your k value is always equal to y over x. If I find the k value with an orange point, maybe I have x1, y1, it's still going to give me the k value. Let's say I have a green point. We'll call that x2, y2. And I find my k value, it would be y2 over x2. I'm still going to get the exact same k value. Because it doesn't matter what point I use, I always have the k value. And it's always going to be the same because y varies directly with x. Because it's a direct variation equation. So that means that I can take and say that if this k is equal to that k, the orange k equals the green k. And because of that, I know that if I find k with that orange point using y1 over x1, that'd be the same way of finding the k value with the green point. So the setup here is y1 over x1 has to equal y2 over x2. And then what we're going to do is we're going to fill in what we know. The green point here, our y value is 10 and our x value was 3. And for our orange point, the x value was unknown, but the y value was 6. So far, so good. Now get rid of the fractions. By multiplying both sides by 3, that will get rid of your denominator over here. And then if you multiply both sides by x, it gets rid of your denominator over there. And what we're left with is 3 times 6 is 18 equals 10 times x is 10x. Now some people know that if you have a fraction equal to a fraction, you can cross multiply. That is what we just did. We did 6 times 3 on the left and 10 times x on the right. We cross multiplied. That's all cross multiplication is you multiply both sides by each denominator. And it undoes those fractions for you. How do I get x alone though? I'm still looking for that x. Divide both sides by what? Divide both sides by 10. My 10s go away on this side. And I get that x is equal to 18 over 10 though. That can be reduced. What number goes into both 18 and 10? 2. Okay, so 9 over 5. 9/5. And that's our answer. That's our end. Go ahead and do the setup for B like that. Okay, so it says if y is -8 when x is 5, this is 1 point. Now the next point, it gives you x is 2, but we don't know what y is. So that's the unknown there, is y. So go ahead and do your setup here. Give me a 1 through 5. 5, I think I have it. 4, I might have it. I tried it. I got everything, but I'm not sure if it's all right. 3 is like, not so sure if it's right, but I have something. Where are we at? All right, how'd we do? And it is okay if they're flip-flopped. If you have the orange on the right side and the green on the left side, that's okay too. How'd we do? Give me a 1 through 5. I got it? I have no idea where you're at, Mrs. Fox. Not even in the same room, let alone on the same page or in the same book. All right, so far so good then? So then again, we can multiply both sides by 2 and then multiply both sides by 5 and get rid of those denominators. Or you can think about cross multiplying. 2 times -8 is what? -16 equals, what's 5 times y? 5y. Divide both sides by 5. We're going to get y is equal to -16 over 5. Does that reduce? Is there a number that goes into both 5 and 16? No. So we're done. That's it. Now, if you look back to example 3, you could have done this exact same setup because we were given a point and we were given one variable of the next point, but we had one unknown. The problem is if you went this route, you would have y, but you wouldn't have had your constant of variation. You would never have k. And if it asked for the equation, you wouldn't have the equation either. That's why we had to go a different route on those ones. Does that make sense? Okay, let me show you, because first hour struggled a little bit. So numbers 1, 2, 3, and 4, we did exactly this on your notes where you had the table. So do a k column and find your k for all 3 points. If your k is the same all 3 times, answer yes, tell me that k value and write the equation. Y equals that k value x. Okay? 5 through 12, we did examples like this. If it looks like y equals kx. If there's no k, is there no equation? Yes, exactly. If you can't find the k, if your answer is no, there's no k, there's no equation, you don't have to move on. Okay? For the 5 through 12, you're looking at, does it look like y equals a number x? Or can you manipulate the problem to make it look that way if it doesn't already look that way? Okay, I definitely would recommend following along because there's one problem that a lot of people struggled on in first hour, and it's what made a lot of people not finish. 13 through 16, this one you have to find the k value, you have to find the equation, and then you have to find y. So you're not going to be able to set up a fraction equals a fraction and cross multiply on this one because you have to instead find k, write the equation, then plug in x is 5. Okay, so use this as your first point to come up with the equation, and then it says to find y when x is negative 5. So this would be like your second point idea. Okay. All right, then for the next page, on the back side, this is where everybody got stuck in first hour. So I'm going to read it with you so we can make sure that we figure this out today. It says, suppose you work on a tree farm and you need to find the height of each tree. You know that the length of an object's shadow varies directly with its height. Here's that sentence. Varies directly with. What comes first, x or y? How is it usually written? Let's read this sentence below. How is it usually written? Y varies directly with x. So this right here, your object's shadow, the length of the object's shadow, has to be y. Okay? Varies directly with. Its height then has to be what variable? That has to be x. Okay, so these heights have to be x. That means the shadows are the y values. This person is 1 point, so that's an x1 and a y1. This tree is a 0.2, so we'll call that x2 and y2. So that will probably help you. Another thing is, if you read this, it says convert all measurements to inches. That's your hint. How many inches are in 1 foot? 12. So if I have 6 feet, how many inches would that be? How can I figure that out? 6 times 12. So what's 6 times 12? What is it? Okay, so that has to be 72 inches then. Okay, 2 feet and 2 inches. You need to change that to inches, just inches. How many inches is 2 feet? How many inches is 2 feet? 24 plus another 2 is 26 inches. So I'd write 26 inches there. Okay, here's an 8 foot 4 inches. So you want to change everything to inches. And this problem will be no different than problems 13 through 16. Okay, because you're given 1 complete point and you have half of another point. 18 through 21, this one does not tell you you have to find k. So if you want to set up the fractions and do cross multiplication, you can. Okay, so that's an option on those last ones. But you guys have the rest of the time to work today.